Hello dear students, this is Ramaram sir, lecturer in physics, IIT Rajendra. Today I will going to start the main concept of mechanical properties of solids. Okay. Mechanical properties of solids. In this first we should have to discuss intermolecular energy. What is an intermolecular energy? Intermolecular energy. Intermolecular energy. Suppose consider an atom or substance which is contains how many number of molecules, which is contains how many number of molecules like this. This is a substance which contains so many number of atoms and molecules. Okay. Consider here is a substance which contains so many number of atoms and molecules like this. Okay. Consider a molecular system in this. So the molecules would be presented like this here. The molecules are presented in the corners like this. These are the molecules. Okay. Imagine that these molecules are connected with the spring system. Imagine that these molecules are connected like this spring system. So one of the string. This is another one of the string. This is one more of the string. This is also one more of the string. This is also one more of the string. This is between the molecules a spring is connected. This is one imagination only. Okay. This is a spring system, spring mass system. Okay, this is when we have applied some amount of force in any direction like this. Suppose when we have applied some amount of force in any direction like this, F newtons or F newtons when we have applied on the surface, what happening is that these all molecules are undergoing to simple harmonic motion. When they are going to simple harmonic motion, this each and every molecule would be applied some amount of force of our existing force. This molecule, this molecule, this molecule, these all molecules are experiences opposite direction of force of our applied force. This opposite direction of force only existing due to the electrostatic interaction between the molecules. The electrostatic interaction force between the molecules is called as this is called what is that? Intermolecular energy or intermolecular force. This is also called as intermolecular force. This intermolecular force is also called as restoring force. What force? This intermolecular force is also called as restoring force. This is a restoring force. Due to this force, some amount of energy has to be developed in this. That energy is called as intermolecular energy. The intermolecular energy must be presented between the molecules in the form of and potential energy. So between any two molecules, some amount of energy has to be presented. This energy is called as what energy? Intermolecular energy. This intermolecular energy will be stored in the form of potential energy. So when we have applied some amount of force, so how would be the distance between the molecules each and see here? So when we have drawn the graph between force and distance, intermolecular force and distance. This is the intermolecular force and distance with respect to distance between the atoms. This is an intermolecular force. Okay. The force will be gradually decreased due to repulsion force. The force will be gradually decreased. It will be minimum here. With respect to radial distance or not, it would be minimum. Again, what happening is that due to attraction, this force will gradually increase like this. Okay, this is a repulsive force. Repulsion. This is a repulsion force. This is a attraction. Due to attraction, what happening is that the distance is again increased. Attraction. Due to attraction, what happening is that again the distance between the molecules is increased. Okay. So how would the potential energy has to be changed? That means the potential energy has to be changes between the molecules due to this. Here see, the potential energy has to be changes like this. The potential energy with respect to distance or the potential energy has to be changes like this. Similarly, the potential energy also gradually decrease. It will be minimum at this point. Again, what happening is that increase. So this is a minimum value. This is a minimum value, U minimum. So this is a distance between the molecules in ultimate R naught. So this energy has to be varies according to the distance is given by U of R is equal to A by R power of P minus B by R power of Q. So like this, the intermolecular potential energy has to be changes. Okay, that is U of R is equal to what is U of R? U of R would be is equal to A by R power of P minus B by R power of Q. This is a variation of the intermolecular energy between the molecules. Okay. So when it would be max and when it would be minimum with respect to change of the forces. Suppose if at infinity distance, at if R tends to infinity, when the R tends to infinity, the intermolecular potential energy would be is equal to 0. With long distances, the potential energy would be is equal to 0. So at the equilibrium condition, it would be maximum. So at the equilibrium condition, what is happening is that the force of interaction between the molecules is given by F is equal to minus du by dr. Du by dr. But at the equilibrium condition, at the equilibrium condition, what happening is that at the equilibrium condition, what happening is that U is equal to constant. Equilibrium condition, the potential energy will not change. That means it will be constant. When the potential energy is constant, the intermolecular force of interaction between the molecules is given by F is equal to minus d by dr of constant. So constant derivative of constant value is 0. In the equilibrium condition, potential energy is constant, but interaction force is 0. So the infinite distance, what happening is the potential energy will be equal to 0. Is it clear? Is it clear or not? Respondent is clear now? Next. Now let's see how to discuss due to this force. How would be the this force is expressed the force of our external active force on an object. See, that is called as a stress. What is the stress? Yes. Suppose consider an object. Suppose consider any type of object like this. Suppose consider an object. This is an object. Okay. This is an object. We have it has the area of the cross section. We have applied some amount of the force on this like this. We have applied some amount of force on this like this. This it has the area of the cross section here like this. Okay. We have applied some amount of the force on this. Okay. The intermolecular force must be acting opposite direction. This is called as the restoring force. But magnitude of Fr minus of Fr is equal to magnitude of F applied force, both will be equal. That is because simply F is equal to Fr. Restoring force would be is equal to what is that? Our applied external force both will be equal in magnitude, but directionally they would be in opposite directions are there. Okay. This restoring force acting per unit area. Per unit area. Let's take this per unit area. The restoring force acting per unit area is called as the stress. What is this? Stress. Stress means the restoring force acting per unit area is called as a stress. This is called as stress. So what are the units? Units you see here. Units of the stress are Newton per meter square, or this is also called as the Pascal. Newton per meter square or Pascal. Its dimension formula is what is the dimension formula? Dimension formula is F is equal to ma t power of minus 2 upon the dimension formula of the A is L square. Where L gets cancelled out, that is equal to m L power of minus 1 T power of minus 2 is a dimensional formula of the stress. Okay? Stress means the restoring force acting per unit area on an object is called as a stress. It is denoted by the stress that is called F upon A. The F is called as force. A is nothing but area of the cross section of the object. Next, this stress is again divided into three types. They are first one longitudinal stress. Longitudinal stress. So what is the longitudinal stress? Longitudinal stress means the restoring force acting along the length of an object. Suppose consider an object, it has some amount of the length L, it has some amount of the length L. Okay, we had applied some amount of force like this direction. So what happening is the restoring force is acting along the direction of our applying force on the civil area of the cross section. It is also the longitudinal stress is nothing but what is that? Longitudinal stress is equal to F upon A. It is also has the same units and dimension, that is the Newton per meter square. The stress, what is the longitudinal stress? The stress which is acting along the length of an object is called as the longitudinal stress, simply. It is denoted by F upon A, it is also as Newton per meter square. Next to normal stress. Normal stress. This is also called as bulk stress. Bulk stress. Bulk stress. So what is the normal stress? The restoring force acting normal on the surface of an object is called as a normal stress, and this is also called as bulk stress. So this is I am representing like this. Suppose consider an object. The object would be like a shape is there. This is an object. Okay. This is an object. This is an object like this. Okay. I have applied some amount of force on it. It is the area of the cross section is equal to A. How much amount of the force acting? F amount of the force will be applied on this object. Restoring force will be acting opposite direction of our applied. This is called as FR. FR means restoring force. Right? So the normal force acting per unit area is called as the normal stress. It is also denoted by N stress, that is equal to FR or F N upon A. FR by A or Fn upon A is called as the normal stress. It is also has the same units and dimensions, Newton per meter square and same dimensions. Okay, is it clear? Next third one is the shearing stress. Shearing stress. What is the shearing stress? The stress which is changed the shape of the object is called as a shearing stress. The stress which is changes the shape of an object is called as a shearing stress. Yes. Suppose consider an object. This is an object. The object will be like this: A, B, C, and D. When I have applied some amount of the force on this like this, what happens is there? The shape has changes like this. The shape has changes like this. The shape has changes like this, making some angle theta. Okay, but it is also acting on same unit area only. This area of the cross section only. This is called as the shearing stress. That is, shearing stress would be equal to F upon A. It is also has the same units and dimensions of the stress. Is it clear? Stress means what is stress? The normal reaction force acting per unit area is called as stress. It is of how many types are there? It is of three types. First one is the longitudinal stress. The stress which is acting along the length of an object is called as longitudinal stress. Next, second one is the normal stress or bulk stress. The stress which is acting normal to the object is called as the normal stress. Next one is shearing stress, the stress which is acting, but is that which is changes the shape of an object is called as the shearing stress. Okay, is it clear? That is called as stress. So based on this concept of the stress, see one problem. Suppose consider a rod of length L. This is a rod. It has a mass M and length L. Suppose consider a rod. This is a rod elevator. It has a mass M and length L. See one problem based on the concept of the stress. Okay, the rod has a mass M and length L, and I had applied some amount of force at this end. How much amount of the force? F much amount of the force is applied like this. Then, when I had applied a force of F Newton on the object, it is accelerating with an acceleration A, with an acceleration A, that's all. It is accelerating with an acceleration A. Then calculate the stress at a distance of x at this point. Let's say this is. Then calculate stress at a distance of x from the applied force. At this point, we should have to calculate stress would be equal to how much there. At this point, we should have to calculate what is the stress. At this point, we should have to calculate stress. What is the stress here? What is the stress? Let's take it has a area of the cross section A like this. Calculate the stress. I showed in the figure simply. So what was taken? This object was taken rod. This is a rod. Find the stress. Find the stress at point P. At point P, I showed in figure. Here, let's take this point P. Okay. At point P, we should have to calculate how much amount of the stress would be acting there. How can we calculate? See here. When we had applied a force of F newtons, the object would be moving with certain acceleration. So first we should have to calculate the acceleration. What is the acceleration? The acceleration of the object A is equal to F driving by M total. Already you know total mass of the system. F driving means F upon M total is nothing but M. So this is the acceleration of this rod. Okay, at this point P, the stress only exists due to only this mass only. Which mass? This mass only. Only this mass. Only this mass. Only this mass only responsible. The stress will be produced at this point P. Okay. Whatever this mass, we don't know. Let's take the mass would be equal to, you should say, m dash. Okay. The rod has a what mass density? It has a linear mass density lambda. Already you know what is linear mass density. But lambda is equal to mass per unit length is equal to constant. That is equal to mass by length is equal to constant. Capital M upon L is equal to, we have taken this mass is m dash upon whatever this length. Whatever this length, total length is already given L. This point we have taken x. This length would be equal to L minus x. This length would be L minus x. Is it clear? Okay. Lambda is called m by L upon m dash by L minus x. So from this, m dash is equal to, what is the value of m dash? M dash is equal to m by L into L minus x. So this part will be contains m dash is equal to m by L into P minus x. Okay, is it clear? So this was only responsible here tension. How much tension will be produced? Let's say T, take there. Therefore T is equal to the tension force at that point is given by T. P is equal to m into A dash. M dash into A dash. That is T is for m dash value also already know what is m dash value. M dash values are m upon L into L minus x A dash value also already know. What is the value of A dash? A dash, that means acceleration. A dash means their acceleration. What is the value of A dash? A dash means acceleration. Are you following or not? What is the value of A dash? A means acceleration. No? The acceleration would be equal to F upon M. This is a F upon M. Okay? You should cancel out M in the numerator and denominator. The stress would be is equal to F upon F upon, this is L I am writing like this, L minus X upon L, and on both sides dividing with A, okay, that is T upon A would be equal to F upon A into 1 minus X upon L. So this much, this is called as the force. Tensional force means the force acting per unit area is called as, what is this called? Stress. Tensional force acting per unit area is called as stress is equal to F upon A into 1 minus 1 minus X upon L is called as a stress. The stress acting at the midpoint is given by how much? What is that? F upon A into 1 minus X upon L. Understood or not? All of you are following? Okay? बहुत आसान है. ऐसा दिया we should have to calculate what is the stress is equal to F upon A into 1 minus X upon L. Okay? Next to see. The potential energy between the molecules of a diatomic model or diatom. Suppose consider two molecules. These are two molecules. Okay? These are two molecules. The potential energy between the molecules has to be given like this. The potential energy between the molecules has given U of R is equal to A upon R power of 12 minus B upon R power of 6, which is changes with respect to radial distance between the molecules. The potential energy was given between the molecules of a diatom. U of R is equal to A upon R power of 12 minus B upon R power of 6. Then find the difference of potential energy. The difference of potential energy U of R tends to infinity, one condition, minus U at equilibrium. U at equilibrium. Find the potential energy. U of R is equal to infinity distance and U at equilibrium condition. These are very important for the mains purpose. Okay. What should we have to calculate? The difference between the potential energy at the infinity distance and potential energy at the equilibrium condition. When they are vibrating like this, after a certain amount of the time, they will have to at a stable equilibrium. When they are at a stable equilibrium, both of them, how much amount of the potential energy has to be stored of that system. So the difference we should have to calculate now. Okay. Let's take first one condition at infinity distance. At infinity distance, what happening is that at infinity distance, U of infinity would be equal to 0. When R is equal to infinity, U of infinity would be equal to 0. It is very clear. At the infinity distance, potential energy of the system is also 0. Already knows. Next, at the equilibrium condition, next we have to calculate the equilibrium condition. At the equilibrium condition, at the equilibrium condition, okay. So what is the potential energy? That is we should have to calculate now. That is F is equal to the force between the molecules is given by minus du upon dr is already knows. Okay, du upon dr. But at the equilibrium condition, U is equal to constant. Potential energy would be constant. That is a constant. Therefore, the force of interaction between the molecules is given by, what is that? F is equal to minus d upon dr into constant. Derivative of constant value is equal to 0. Derivative of constant value is equal to 0. Therefore, the force of interaction at the equilibrium condition would be equal to 0. So, this is applied for this equation. Therefore, F is equal to minus d upon dr into, what is the value of U? A upon r power of 12 minus b upon r power of 6. Okay? So, this is what I am writing. This is what I am writing, see, into d by dx of into x power of minus 1 value is minus 1 into x power of minus 1 minus 1, that is minus 1 upon x power of minus 2, that is equal to minus 1 upon x square. Simply this is I am writing like this form. Okay? D by dx of x power of n is equal to x power of n minus 1 is already, or d by dx of x power of n is equal to, what is that? N into x power of n minus 1. Like that form I have expanded, this is x power of minus 1. You should expand like this. What you will get here, see, that is equal to minus of, this is what I am writing, minus 12 a upon r power of 13, here you will getting plus 6b upon r power of 7. Is it clear? Like that. Okay, you can multiply with, that would be equal to 0. That would be equal to 0. This is what I am writing, see here. 12a upon r power of 13 minus 6b upon r power of 7 is equal to 0. So, this is take outside, then what you will get from this? 12a upon r power of 13 is equal to 6b upon r power of 7. Okay. R power of 7, r power of 13 gets cancelled out. 2 6 1s, 6 2s. Therefore, r power of 6 is there. R power of 6 will be is equal to 2a upon b. 2a upon b. At the equilibrium condition, the intermolecular distance would be equal to r power of 6 is equal to, what we have got it? 2a upon b. Okay. At this distance, how much potential energy it would be possessed? That is, we should have to calculate. Okay. The potential energy possessed at this condition is given by, what is that? What is that? See here. U of r is equal to, U of r is equal to a upon, this is what I am writing, this equation, r power of 6 of whole square minus b upon r power of 6. I have written like this. Okay. Now this value put in this equation. U of r would be is equal to a upon r power of 6 means 2a by b. That is equal to 2a by b of whole square minus, what is that? B upon 2a upon b. This is what I am writing, see here. What is that? This value is what about this value? How would we change it? See here, see ab square. This is ab square upon 4a minus b square upon 2a. While a gets cancelled out, this will be equal to minus b square by 4a. Here one square is there. Okay, that is equal to minus b square upon 4a. Is it clear? Minus b square upon 4a. Now we have to calculate this condition. What is this condition? Therefore, potential energy is given by P of E is equal to U of infinity would be equal to 0. 0 minus already minus is a minus B square upon 4A. This is minus of minus. That would be the potential energy is equal to B square upon 4A. Okay. Is it clear? I hope you may be understood about this problem. Both are problem. The condition was important. What was given in this? Then these two conditions are set. The constant, the force is equal to 0 at infinity, U is equal to 0. Okay. Is it clear? Below, leave. Next thing, next to strain. What is a strain? Strain. Suppose constrained object, when we have applied some amount of the force on this like this. Suppose constrained object, any one of the object like this. I am taking one of the rod or any object we should consider like this. When I had applied some amount of the force, what happening is there? Its length is gradually increases. A small amount of the length would be increased. That is called delta L, which is represented by E. That is called the change in length by its original length is called as a strain. That means if this is a change in dimensions. What is this called? Change. Change in dimensions. This is a change in dimensions. This is the original dimensions. Okay. The ratio of change in dimensions to original dimensions is called as a strain. Strain means what is that? It is a ratio strain. Change in dimensions. Strain would be equal to strain. Strain is the change in dimensions upon original dimensions. Original dimensions. Original dimensions. Change in dimensions upon original dimensions is called as a strain. It has no universal dimensions because of both of them are in the form of dimensions. Next, this strain is again divided into three types. This strain is again divided into three types. They are first one. This strain is again divided into three types. This strain is again divided into three types. They are first one. Longitudinal strain. Longitudinal strain. Longitudinal strain. What is the longitudinal strain? See, suppose consider the same rod. This is a rod. Okay. It has a length here. It has a length here. Suppose I had applied some amount of the force at this point. I had applied some amount of force F. Then what happening is it has to be elongated a small length. Delta L. Delta L or this is also represented by E. Therefore, it has some area of the cross section also. What is the area of the cross section of the rod? Let's take A is the area of the cross section of the rod. This is A. A is the area of the cross section of the rod. Longitudinal strain is equal to change in length by original length. That is equal to delta L upon L is called as a longitudinal strain. This is a longitudinal strain. Longitudinal strain can be defined as change in length to original length is called as a longitudinal strain. Next to is a longitudinal strain. Next one is a normal strain or bulk strain. So bulk strain. The bulk strain is generally defined as suppose consider a sphere. Okay. Initially it has a volume V. When I had after some amount of the force like this across them, when I had applied some amount of the force like this across them, what happening is its volume has to be decreased like this, delta V. Okay, that means volume has to be changed, decreased to delta V. The volume has to be decreased to delta V due to this external force. Okay. So this is called as a volume strain or bulk strain or normal strain. Normal strain is also called as a bulk strain. It's also bulk strain. Bulk strain is generally defined as what is that? Change in volume to original volume. That is equal to delta V upon V. I am writing that negative because the volume has to be decreased. That's why I have written what is that? Bulk strain will be equal to what is the bulk strain? Bulk strain is equal to change in volume by original volume is called as the bulk strain. Next, third one is a sharing strain. Third one is a sharing strain. Sharing. Third one is a sharing strain. Third one is a sharing strain. What is sharing strain? See here. Suppose consider a cube like this there, cube, or any object will be like this there. I had applied some amount of the force across there. Its layer has to be displaced like this. From A to A dash it has to be displaced, making small angle theta. This length is delta x, and the perpendicular distance would be equal to L. Okay? Where theta would be written as what is the tan theta? For small angles, tan theta is equal to theta is equal to delta x upon L is called as a sharing strain. This is called as sharing strain. This is a longitudinal strain. This is a bulk strain, and this is also called as sharing strain. Is it clear? These are the types of the strains. How many types are there? These various types are there. Okay? Longitudinal strain, bulk strain, and sharing strain. Next, see the next concept is the Hooke's law. What is the Hooke's law? Hooke's law. Within the elastic limit. What is an elastic limit? Elastic limit means the maximum strain when we have applied an object, if the body regains its original position, its original shape and size. So that is called as elastic limit. Elastic limit means even though we had applied the maximum strain on the object, after removing the maximum strain, if the body gets in original shape and size, that limit is called as an elastic limit. So within the elastic limit, stress is directly proportional to strain. So I state that within the elastic limit, within the elastic limit, within the elastic limit, what happening is that stress is directly proportional to strain. Stress is directly proportional to strain. This is a strain. Stress is directly proportional to strain. Or stress is equal to what I am writing? Stress is equal to some constant E into strain. E into strain. Or E is equal to what is the E? E is equal to stress upon strain. Stress upon strain. What is the stress? Stress means force upon area, and strain means change in dimensions by original dimensions. These don't have any units. Okay? So it has units and dimensions. Therefore, E is equal to F upon A. That is called what is it? Newton for meter square is called as a. This constant is called as a modulus or elastic modulus. Elastic modulus. Elastic modulus. It has a student for meter square or positive. It also has a positive. Okay? Elastic modulus. This is called as elastic modulus. This elastic modulus is again divided into how many types? 3 types. They are first one Young's models. Young's models. It is denoted by Y. What are the Young's models? Y? Stress upon strain. So in this case, stress upon strain means Y is equal to suppose consider what happened in the rod head. The rod stress of force लगा दिया, इसमें कितने एक्सपेंशन हो गया, डेल्टा एक्सपेंशन हो गया. This length would be equal to L is already known. Okay. Y would be written as what is Y? Y is equal to longitudinal stress. Longitudinal stress upon longitudinal strain. Longitudinal strain. Longitudinal stress to longitudinal strain is called as a Young's modulus Y. This is what I am writing. See, Y is equal to F upon A upon change in dimensions कितने बेटा डेल्टा है वर्जल length L डेल्टा L is equal to some marks at A वर्जल length Y is equal to FL upon A delta L or FL upon A E. Instead of delta L, you can consider E. FL upon A into delta L. So what are the limits? Units are Newton for meter square. Newton for meter square. Suppose F is in the form of a weight. F is in the form of a weight. Then Y is equal to what I am writing? See, suppose consider what is that a wire है, wire ऐसे है, a wire ऐसे है, इसका weight MG नीचे है. It has some amount of the radius or area of the cross section A is equal to pi r square. So in this case, the Young's modulus should be, I am writing like this, Y is equal to mg into L upon pi r square into E. This is called as an Young's modulus. What known as Young's modulus. So from this it is very clear that Y is direct proportional to L upon pi r square. Sorry, L upon what I am writing, see here. Y is direct proportional to L upon r square into E. If this is a constant, then what I am writing, see here, y1 upon y2 is equal to L1 upon L2 or R2 upon R1 whole square into E2 upon E. We should have to write like this in the form for the different metals. Is it clear? What are the Young's modulus? Young's modulus means what is Young's modulus? The ratio of longitudinal stress to strain is called as Young's modulus. So which units are denoted for meter square. For different metals we should have to write like this form. Is it clear? Is it clear or not? Okay, right. Next see, based on the Young's modulus, see some problems here. This is a JEE 2025 में पूछा this problem. Okay. Suppose consider a wire. This is a wire. A wire of this is a wire. A wire of 1 is fixed here like this. So a wire of 1 is fixed, and it has a length L is equal to 3 meters. And its radius should be equal to what the radius? This is the radius. The radius R is equal to 3 millimeters. Okay. At the end, what did I do? A block of mass 50 kilograms. M is equal to 50 kilograms is a hand at this point. A block of mass 50 kilograms is attached like this. A block of mass 50 kilograms is attached at this point. 50 kilograms attached at this point. Okay. Due to that, the elongation produced is equal to 0.1 millimeters. 0.1 millimeters. Then calculate the Young's modulus of the wire and find the Young's modulus. Young's modulus. Young's modulus of the wire as shown in figure. All values was given, its length was given, elongation given, mass given. What should we have to calculate from this? We have to calculate the Young's modulus. What should we have to calculate from this? The Young's modulus. The Young's modulus the y would be equal to how much? Y. We have to calculate y. Okay. कैसा करना है बोलो? है ना हमारा Young's modulus का एक्सप्रेशन बहुत आसान है. What is Young's modulus? Y is equal to FL upon A E. Here one more quantity. Take G is equal to 35 meter per second square. Take G is equal to 35 meter per second. तो भी अभी करना पड़ता है. बोलो इसको कैलिग्राम y is equal to mg into L upon A value I am writing in the form of it is pi r square into E, where R value was given 3 millimeters. That's what I have written A value in the form of pi r square. Okay, that is y is equal to what is the value of L? 50 kilograms. G value is 35 was given. Take G is equal to 35 meters per second square. What is the value of L? L is equal to into 3 meters was given upon pi into R square. R value is 3 millimeters. That is 3 into 10 to the power of minus 3 meters. Into E value also given 1 into 10 to the power of minus 4 I am writing because of 0.1 millimeters. 0.1 means 1 into 10 to the power of minus 4 meters. Okay. All values I have substituted pi r square. You should write r square here like this. Okay. Here pi will get cancelled out. Next to pi will get cancelled out here. The remaining term is what is the value of y? Y is equal to 50 into 9. 50 into 9 upon 9 into 10 to the power of minus 6 whole square into 10 to the power of minus 4. Is it clear? Here 9 also gets cancelled here. That is y is equal to 50 into 10 to the power of 10. Okay. That is y is equal to 5 into 10 to the power of 11 Newton per meter square. This question was asked in 2025 JMS. ऐसे बहुत आसान है नहीं? बहुत आसान है नहीं? देखो a wire of length 3 meters was given and its radius was 3 millimeters was given. This is the total wire of length was given. How much? 3 meters. And it has a radius r is equal to 3 millimeters. Okay. When a 50 kilograms mass has to be attached at one end, the elongation produced in the wire was 0.1 millimeters was given. And the problem also was given, take G is 3 meters per second square, then calculate what is the Young's modulus of the wire. How we have to calculate the Young's modulus of the wire? Let's go to our Young's modulus principle. Y is equal to FL upon A. That is FL upon A value having in the form of what is that? The wire has in the form of what is the circular path diameter. So that's what I have in past reading. So y is equal to 5 to 10 per meter. Okay. Is this clear? Right. Next you see, suppose consider a wire, this is a wire, this is a wire. When a force of F1 Newton is applied in this, the length of the wire will be is equal to L1 over here. On the same wire, this is the same wire only. Okay. When a force of F2 newtons is applied, so the length would be is equal to L2. The length would be is equal to L2 only. So in this we should have to calculate. So what is the original length of the wire? What is the original length of the wire? This question was asked in JEE 2022 based on the Young's modulus. Okay. When F1 newtons is applied, what happening is that its length would be L1. When an F2 newtons force is applied, its length would be L2 newton, sorry, L2 meters only. So we should have to calculate the natural length of the wire will be equal to how much. Okay. इसमें elongation कितने हो जाता है? What is elongation means? We don't know. Let's check this E1. इसमें कितना हो गया? Let's take the elongation will be equal to E2, and the natural length of the wire we don't know. That is, let's we have to take in what is that L. Okay. In the first case, the elongation would be equal to what is that? E1 is equal to L1 minus L1, because of this L1 length is greater than to L, because of we had applied some amount of force at one end. E1 is equal to L1 minus L. In the second case, what is elongation in this? Elongation E2 would be equal to L2 minus L. L2 must be greater than the natural length, because of we had applied some amount of force at this end. Okay, so that's what L2 must be greater than to L. The wire is same. The nature of the wire and material does not change. Therefore, it has the same Young's modulus. Y is equal to Y1. Here Y2 is equal to also Y1, because of both the wires are same. It has the same Young's modulus, but forces are different. Therefore, from the principle of the Young's modulus is already known. Y is equal to what is that? Y is equal to FL upon AE. FL upon A. FL upon A. So Y constant where? Okay. And area of the cross section also remains constant only. So from this Y1 would be is equal to Y2. Both will be equal because of both of them have the same materials. So the Young's modulus is also equal. Y1 means F1 L1 upon A E1 is equal to F2 L2 upon A E2. Okay. So here see, whatever gets cancelled, A also gets cancelled out. So F1 L also gets cancelled out here because of the natural same only. Where L1 is equal to L2 is equal to L1 only. Natural length would be same. This is let's take L. This also you should have to consider L only. Consider L only. This also L. That is equal to L. That is equal to L. Okay. L gets cancelled out on both sides. Then the remaining term would be equal to F1 of E1 is equal to M2 upon E2. You can do cross multiplication. Then what you will get? F1 into E2 is equal to F2 into E1. But E2 and E1 values are already known there. This is a value of E1 and this is a value of E2. These two values are substituted in this equation. Then what you will get? See, F1 into E2. E2 means what is that? L2 minus L. That is equal to F2 into E1. What is the value of E1? L1 minus L. Okay. That is we can do simplification about this. F1 L2 minus F1 L is equal to F2 L1 minus F2 into L. Now we have to calculate the natural length of the wire from this equation. So that's what I am doing here. This term is takes this side. and this term we are bringing this side. Then what we will get, see here, F1 L2 minus F2 L1 is equal to L take common from these two terms, F1 minus F2. Therefore, L value is F1 L2 minus F2 L1 upon F1 minus F2. This is the natural length of the wire. Is it clear? This is the natural length of the wire. The natural length of the wire is given by L is equal to F1 L2 minus F2 L1 upon F1 minus F2. Okay. बहुत आसान प्रॉब्लम. This question was asked in 2022. Next problem. Suppose consider a pulley. This is JEE Mains 2025 का question है बेटा. This question was asked in 2025 JEE Mains. Suppose consider two blocks are connected like this in a pulley block mass system like this. The pulley is connected like this. Across them, two strings are hanging like this. So one string only, one string is hanging like this. This is a 2 kilogram mass. One end is connected to 2 kilogram mass, and second end is connected to 4 kilogram mass. Okay, 4 kilogram mass. And its x-mass was given. Y is equal to 2 into 10 to the power of 11 Newton per meter square. And its radius was given. The radius of the wire R is equal to 4 into 10 to the power of minus 5 meter square was given. Okay. 4 into 10 to the power of minus 5 meter, so 4 into 10 to the power of minus 5 meter square was given. Due to this uneven weights, calculate the strain produced in the wire. Find the strain produced in the wire. Find the strain produced in the wire. Calculate the strain produced in the wire. Okay. So how much amount of the strain has to be produced? See here, y is what is already known. X plus y is equal to FL upon A into delta L. This is what I am writing. See here, delta L upon L is equal to F upon A y. F means what is F? A tensional force. Beta. We have to calculate the tensional force. This is what I am writing. This F stands to tensional force, that is T upon AY. T upon AY. This is A into Y. Okay. The strain produced in the Y is given by delta L upon L is equal to T upon pi r square into Y. We have to calculate. Next, we have to calculate the strain. How can we have to calculate the strain? See, this is looking like a outward machine. For the automotive machine, the tension force is given by T is equal to 2m1 m2 upon m1 plus m2 into G. G value is not given. Take G is equal to 10 meter per second square. Therefore, T value would be equal to 2 into m1 m2 value is 2 into 4 8 upon 6, 2 plus 4 is equal to 6 into 10. Okay, is it clear? 2 1 the 2 3 the, that is equal to 80 upon 3 newtons. This much tension force will develop due to this uneven weights in the strings. Okay. Next, come to the point. We have to calculate, our aim is we have to calculate the strain. Now all values are there. Now this value substitute here. Then you will get the strain produced by the wire due to uneven weights. That is delta L upon L is equal to T value is 80 upon 3 is whole divided by pi. R value also given 4 into 10 to the power of minus 5 of whole square. That means 16 into 10 to the power of minus 10 I am writing. Okay, this is square term. Square means what we will get? 16 into 10 to the power of minus 10 into y. Y value also given. What is the value of y? Y is equal to 2 into 10 to the power of 11 was given. 2 into 10 to the power of 11. Okay, is it clear? 10 to the power of minus 10, 10 to the power of 11, this 10 will get cancelled out. And the remaining term would be delta L upon L is equal to 8 upon 3 pi into 16, okay, into 2. This is in the form of into only. Okay, 8 ones are 8, 2 is 16. That is delta L upon L is equal to 1 upon 2 to the 4, 4 3 is 12 pi. This much amount of the strain will be produced in this wire. Okay. I hope that you may be understood about this problem. It is a very important model for JMS 2025. It was asked based on the mixed concept. First one is the force and second one is X mass. Okay. Continue.
Questions?
Okay. Dear students, if you have any doubt today concept, please call me on the scrolling number. First one is stress, strain, next modeling, Young's modeling, and different types of the problems on JEE Mains and Advanced. So on this concept, do you have any doubt? Please call on the scrolling number on the screen. Okay. Please respond, anyone. Okay, thank you. Okay, sir, Marcus.